Hello and welcome to Clayton campus of Monash University. This is the Monash Earth Sciences Garden. My name is Dr. James Driscoll. I'm a sedimentologist here at the School of Earth, Atmosphere and Environment. The reason it was built is we wanted to have an innovative, cutting-edge, state-of-the-art teaching area for our Earth Sciences students. That includes geography, geology and climate science. We wanted them to have the ability to actually undertake their fieldwork studies and get ready for fieldwork studies by using real-world examples of the rocks and the sediment and the weather station, etc., etc. There's 20 different types of rock here in the Earth Sciences Garden. They weigh up to about 13 to 14 tons. It took about a year for us to get everything together. It meant that we had to go to various quarries here in Victoria to find the right type of rocks that we wanted in order to showcase Victoria's geological and geographical history. So it's 20 different types of rocks: sedimentary, igneous, metamorphic. We also have every single rock, there's over 500 of them, in exactly the right orientation. That means the right way is positioned so that our undergraduates can map the entire garden and tell a hundreds of millions year old history of how this garden formed in the geological past. And so this is one of my favourite parts of the garden, because this shows here that Victoria has had a really rich volcanic history in its past. Okay, that's pretty cool. So this is a volcanic bomb. This rock here is an igneous rock. It's an extrusive igneous rock, so therefore this is lava. It's been blown out of a volcano. It's a volcanic bomb, and it's probably about, this is half of it is shown here, so it's probably about 1 meter wide, 1 meter high. So it's a pretty big rock thrown out of a volcano, and this particular rock is from the central part of Victoria, a place called Caragullac, also known as Red Rock, which is right next door. And this is only 8,000 years old, this rock here, and it's from a volcano. So what does that tell us? It kind of tells us that Victoria had volcanoes erupting 8,000 years ago, which is pretty cool. But why do we have that? Let's go and have a look. So, we're in a different part of the garden now. Where we were before, we saw some volcanic bombs which were about 1 meter across, and they're only 8,000 years old, which shows that we've had active volcanism here in Victoria in the last 8,000 years ago. Now that's really amazing, because we wouldn't normally expect volcanics in an area like Victoria. Victoria is not on the plate margin, so Australia is right in the middle of the Indo-Australian plate, so we're not at the edge of the tectonic plates, which means we don't get a typical volcanic environment we get where two plates are coming together, called convergent plates, where one plate's subducted underneath another, and we end up with big, nasty volcanoes like Vesuvius and Mount St. Helens, Mount Fuji, for instance, Mount Merapi over in Indonesia. Those type of volcanoes are associated with plate margins. We don't have that here in Australia. In the middle of a plate, we're not near the plate margins. So how do we get it? We're heading northwards. It's thicker in the centre of Australia. The crust at the back end, where we are in Victoria, it's not quite so thick. And so what happens is, it's almost like you've got the mantle underneath the crust is being churned up, and every now and again one of those little pods of material goes through the crust and reaches the surface of the earth. And that's what's happening here in Victoria. And what we get are really cool things like these. So these are basalt columns. We can see basalt columns. Basalt is a type of igneous rock. We find these at the Organ Pipes National Park. Why is it called the Organ Pipe National Parks? Well, if you look at them, they kind of look like long cylinders, almost like if they were organs in a church. I just wanted to say two things quickly. First of all is this. It's a bit heavy. So this is another volcanic bomb. Look at that. It's almost like it's got a stream-like shape to it. So you can actually see that this piece of magma or lava as we call it, when it gets blown out of a volcano or comes to the surface of the earth, it's got like a streamlined shape because this was a big fat slug of lava which came out of the volcano. It got streamlined because it's still kind of like a solid liquid hybrid, I suppose, and you end up with these bombs forming. The reason I wanted to show you these is because there's another one just here, is because of this stuff here, this olivine, or it's like a greenish color mineral, and you can see where this again has been flown through the air and streamlined as it's come out, so it's got an aerodynamic shape. This is pretty cool because this is olivine. This is a piece of the Earth's mantle. We see lots of these olivine kind of bombs here in Victoria. So if any of you have ever surfed down at Bells Beach, like I haven't, or if you go to any of the beaches down towards Fairies Inlet, for instance, is another area where you'll be able to see this type of rock here. This is another sedimentary rock, which means it's made from sediment. And this is pretty cool. All rocks are cool, but this one's also pretty cool because what we can do is we can actually look at this particular rock and see different fossils in here, and that kind of again tells us about the environment in which they're deposited. So what I can do is I can actually use a hand lens and I can look at this rock, and what's pretty cool about that is I can see this is packed full of fossils. What type of fossils? Let me show you. So the first type of fossil, which is pretty cool in here, is this. We can see lots of spines of this particular creature. If I turn this upside down, you might be able to guess what it is. Yes, it's a sea urchin. So we have lots of sea urchin spines in here. We get bits of the sea urchin spine. We get pieces of the shell as well in here as well. We got lots of different shells in here. We also get something called pecten shells. This is what pecten shells look like. So again, what we can do is almost go back in time. It's 23 million years ago when this rock was deposited. And by looking at with a hand lens and what's actually in that rock, it tells us the environment which was formed. And another super cool thing we have in the garden is this. This is the Earth Science Garden weather station. And so as you can see, today is a bit warm today. So the temperature is being recorded here electronically. Also the wind direction, the wind speed is also being recorded. And we can use the data collected from the Earth Science Garden within our undergraduate program so that we can actually use real world data collected on site. And so if there's anything weird happening with the weather, so say there's some temperature drop which is recorded here, we can get the students to run outside and actually feel that full change coming in. This may not look like the prettiest rock on Earth, but this is really important, this particular rock, for Melbourne's history. So back in the mid to late 1800s, there was a bit of a gold rush in Victoria. In fact, some of the most productive mines in the world have been here in Victoria. And what we found was that in the mid to late 1800s, Melbourne's nickname was Marvellous Melbourne. And that comes from the fact that there was so much money coming into Melbourne from the goldfields of Ballarat, Chewton, Ararat, Fosterville, which is now open at the moment producing gold, and Bendigo. So all of these areas in central Victoria had a lot of gold associated with them. But so these are really important rocks. These are basically part of Victoria's heritage. What interests me though is another little story associated with them, and that is there's a mineral called pyrite, and I've got some just here. I'll bring it closer to the camera. This is pyrite, and as you can see, it's quite beautiful, and it's got like a goldy kind of colour. What was happening is that lots of people were bringing lots of pyrite in from the mountains and the hills north of Melbourne, thinking they'd struck gold. Unfortunately, pyrite is pretty worthless. So pyrite has actually been given a name called fool's gold. So fool's gold is the nickname given to iron varieties, or pyrites as we also refer to it. So those explorers that found pyrite were bringing it in by the wheelbarrow load to Melbourne and then finding out that it was kind of worthless. So quite a cool story. The gold is still being extracted today in Fosterville, and it's also been at Stawell as well. These rocks here are actually from Stawell. It's actually come from the Stawell mine. We were really fortunate to get these. And if you look through some of the quartz veins here, you can actually see with the hand lens, you can actually see the pyrite, the false gold, which is actually within some of these veins. Just Another thing which is really important in the design of the Earth Sciences Garden wasn't just to put rocks and sediment and soil in certain areas and geomorphological features. The other thing we wanted to do is actually try and put in plants which were sympathetic to the area of Victoria the garden was supposed to be representing. And so behind me, you can actually see some of the plantings that are put in for Western Victoria. So the western part of the Earth Sciences Garden represents the western part of Victoria, and it's here that we find things like grass trees in here, which look really spectacular when they're actually flowering. They've got massive spikes which come up to about 2.5 meters. Okay, well, I hope you enjoyed our tour of the Monash Earth Sciences Garden. It's a unique place to come. It's a unique place to do your undergraduate studies. The possibilities of using this garden are to no end. All of our undergraduate program here in the School of Earth, Atmosphere and Environment use the Earth Sciences Garden for one reason or another. Whether you've got an interest in natural sciences or environmental science, geography, geology, climate science, all of those things are kind of covered by what we teach here at the School of Earth, Atmosphere and Environment. So hopefully we'll see you in the next few years as you start your undergraduate degree. Thanks very much for joining us today. See ya.